Today, we will see how do we graph sine and cosine functions. Now, we have seen different properties of those two functions. What we have talked about is how do we find amplitude and how do we find the period of a function. But now we're actually going to put those properties into work. We're going to use amplitude and period in order to properly graph sine and cosine functions. So the main idea for today is that we will use period and amplitude to graph sine and cosine functions. We're going to see one function at a time. So first, we're going to start with sine function. A sine function looks like this. Three properties that are going to help us to graph sine and cosine function is that the sine function, it's going to start at the origin. So if we're going to be graphing a sine function, your graph is going to start at the origin. This is what the first bullet point is saying. The sine function is going to start at the origin. The second point is that the sine function touches the x-axis at one period and one half of the period. Now we will see how can we find the period and what half of a period in a second, but I want you to keep these three ideas into mind. So the sine starts at 0. The sine touches the x-axis at one period and one half of a period. So the period of this function is 2 pi. We will see how do we find that in a second. And half of the period is pi. And you need to remember that the sine function is going to pass through the x-axis at a full period and one half of a period. And lastly, the sine function is going to have a max and a min at 1/4 and 3/4 of a period. So this is 1/4 of a period. We will find that out in a second. And this is 3/4 of a period. And we'll find that in a second. So we need to remember these three properties here. The sine function is going to pass through the origin. The sine function is going to touch the x-axis at a period and one half of a period. And the sine function is going to have a max and a min at 1/4 and 3/4 of a period. Now, one thing I'm going to mention here is that this is in standard form. Which means that there's no shifts. We will see what do I mean by shifts in a couple of lessons, which is there's times where you're going to have this graph and it's not going to pass to the origin because you might even shift the graph either up and down, left or right. You can move the whole graph. We will see that later on. But all the examples that we'll be showing here, they're going to have no shifts. So let's get started. Remember these three properties. Sine passes through the origin. Sine touches the x-axis at a period and half of a period. And sine has a max and a min at 3/4 and 1/4 and 3/4. Let's get started. Now let's look at our first example here. Again, we need all these properties. We need to find those 5 points. So let's find them. Now the amplitude is the easiest of them all. Amplitude is the number in front of sine, which notice that there's no number in front of sine, so that becomes a 1. There's always an imaginary 1 there. So that is saying that the amplitude for this function is just 1. Now we need to find the period of this function. So the period, you remember, there's 2 pi over b, where in this case, what is the value of b? Well, b in here is equal to 3. So that means that the full period of this function is just 2 pi over 3. So this is the period of the function. That's excellent. Now we need to find the other points as well. We need to find 1/4 of the period. So if I know that my period is 2 pi over 3, then 1/4 of the period is going to be 2 pi over 3 times 1/4, which becomes 2 pi over 12, which is equal to just pi over 6. Now we need to find one half of a period, which should not be that We're going to use the same idea here. I know that the period of the function is 2 pi over 3. So if we want to find out 1/2 of it, then you're just going to multiply by 1/2. So that means that half of a period, that's equal to 2 pi over 6, which is just pi over 3. Let me just circle those things to know what we're really using here. And lastly, we need to find 3/4 of the period. I know that the period is 2 pi over 3. If I want to find out 3/4 of it, then I need to multiply by 3/4. So now this becomes what? 6 pi over 12, which can be reduced to 3 pi over 6, which reduces to just pi over 2. Correct? Yes, correct. So now we have these points now. So our next task is to actually put those points that we found out in the graph. So all the way on the right, here we're going to place the period of the function, which we found it to be 2 pi over 3. At the middle of the graph, so this is 1/2 of the period, which we found it to be pi over 3. Pi over 3. Now this is 1/2. Then right here at the middle of it is going to be 1/4. And we know that 1/4 of the period, we found it to be pi over 6. Oops. Pi over 6. And at the middle here, this is 3/4. So we found that the 3/4 was pi over 2. Excellent. So now we can actually start graphing now, because what are we graphing here? Sine. And what do I know about sine? Sine starts at the origin. So we're going to have a point at the origin. Well, what else do I know about the sine function? The sine function touches the x-axis at one period and 1/2 of the period. We know that the period of the function is 2 pi over 3. So that's where it is right here. And we know that the period of the function is pi over 3, because those are the points that we found out here. Now, one thing that I forgot to put is the amplitude. Let's say that 3 squares, that's equals to 1, and that 3 squares, that's equal to -1. Now, I'm not doing 1 square, because if we do 1 square, you will see that the graph is really small. So I'm going to do 3 squares being 1, -3 squares being -1. And what do I know about my other function? Well, I have a 0, and it starts going up, has a maximum, touches the x-axis, has a minimum, touches the x-axis. So I know that my maximum is right here at pi over 6, and my minimum is right here at pi over 2. So that's all you need. Now we have enough info. Now we're just going to graph. Goes up, touches the maximum, passes through 1/2 of a period. It goes down, it touches the minimum, and then it goes up again. Well, let me redo that shape. So it goes up, max, it goes down, min, and then it goes up. And this is we're just graphing half of it. We will use the same reflection on the other side. Now, Well, let's actually do it. So this is gonna basically be gonna be the same, but now in negatives. So this is negative 2 pi over 3. Half of it is gonna be negative pi over 3. Right here is gonna be pi over 6, negative pi over 6. And right here in the middle is gonna be negative pi over 2. And it's gonna be the same. We're still gonna touch the x-axis of 1/2. We're gonna touch the x-axis at negative period. But now it's going to follow the shape, and here's going to start going down. So I know that I have a minimum right here, pi over 6, and it's going to start going up, and I'm going to have a maximum of 1. So it starts going down and up again and down. And now this is how we graph a sine function. Let's do one more example. So here we have it. We need to find those points again. The amplitude is the number in front, which we found it to be 2. So the amplitude is 2. Now, if we want to find the period of the function, the period of the function is 2 pi over b. Which we found it to be b. We can see here that it's 4. So now that says that the period of the function is 2 pi over 4, which is nothing more than pi over 2. Excellent. So now we want to find 1/4 of a period. So we're going to get the period that we found, which was pi over 2. And if we want to find out 1/4 of it, we need to multiply by 1/4. So now that becomes pi over 8. We want to find 1/2 of a period. So we know that the period is 1/2. If I want to find 1/2 of it, I need to multiply by 1/2. So now that becomes pi over 4. Three-quarters of a period. We're going to get the period that we found out, which was pi over 2. And now this time we need to multiply 1/3. So now this becomes 3 pi over 8, which cannot be simplified. So that's it. So we have our points now. Let's actually place them on the graph. So all the way in the end, this is going to be the period, which we found it to be pi over 2. In the middle, that's going to be 1/2 of a period, which we found it to be pi over 4. Right here, the middle, that's 1/4, which we found it to be pi over 8. And right here, at 3/4, we found it to be 3 pi over 8. We're going to do the same for the other axis, all the way on the left. Negative pi over 2. Right here in the middle, we're going to have negative pi over 4. Middle of the middle, we're going to have negative pi over 8. And right here, 3/4 of it, we're going to have 3 pi over 8 negative. All right, so we got our points. So now we just got to remember those key properties, which it was, well, let's do the amplitude. The amplitude, let's say here that 4 squares are 2, so that's 2, so that's 4. So now, what do I know about the sine function? The sine function passes through the origin. It passes through half of the origin, which we found it to be pi over 4. And it passes through the full period, which we found it to be pi over 2. The same goes for the other side. Passes through the origin to those points. Excellent. So now you know that it starts going, you're going to start at the origin and it starts going up. So that means that you're going to have a maximum. You're going to have a maximum of pi over 8. So let's start graphing here. 0 starts going up. It touches at 1 over 8. And then it starts going down. So that means that it's going to have a minimum here at 3 pi over 8. So it starts going down. And then up again. So that's the same for this. Starts going down, pi over 8. Then it starts going up all the way to 2. And then touch the axis here. So again, all we need is just those 5 points and the 3 properties that we mentioned at the beginning of the video.